So we're going to talk a little bit about the distributive property and how it can be used in a proof. Not the distributive property, I'm sorry, the reflexive property. So we're going to talk about the reflexive property and how it can be used in a proof. The reflexive property says that something is, well, there are two different ones that are basically the same. The reflexive property of equality says that something is equal to itself, and that's used when we're talking about measurements, lengths, things of that nature, where we say like 6 is equal to 6. And hopefully when you see that, you say, well, of course it's 6 is equal to 6. It's the same thing. The reflexive property of congruence is basically the same, except we use that with shapes. So we could say one shape or one side or one angle is the same as itself or congruent. So if we look at a line segment, AB, for instance, okay, and another line segment that is the same thing, same length, okay. Now we could say, for instance, AB is congruent to CD, but we can't. But that's not the reflexive property. So if this is say 7, and this is 7 units over here, okay, then these are congruent, but they're not the same because this is AB and this is CD. They're different. Okay, you could have two people that are the same height, for instance, but they're not the same person. So that's what we're talking about here. So you can have two things that are congruent, but different things. Now, if I say AB is the same thing as AB, that's the reflexive property. So something is equal to itself. So if somebody tells you you are who you are, well, that's the reflexive property. If somebody told you you are just like your brother, then that's not the reflexive property. That would be more like congruence. So one way you can recognize the reflexive property in geometry, the way we're going to be using it, is you look for something that's used twice. Now, what I mean by that is here we have one triangle, and then we can divide this triangle into multiple pieces. So let's say I draw a line down the middle. That forms two different triangles, right? We have one over here, and then of course we still have the larger triangle here. Well, if we look at this triangle right here, we have one side and another side, and if we can right here, and then we have a third side. Okay, so this is our first side, our second side, our third side. I shouldn't have marked them like with congruence right here. Now this side right here of this triangle, that's the first side, that's the second side, and that's your third side. So notice this triangle is using that middle side as its third side. This triangle is using that as its third side. It doesn't have to start out as a triangle, it could start out as a rectangle. We draw something right down up from a diagonal from corner to corner, from vertex to vertex. Our first side, our second side, third side. Here, the first side we're looking at, second side, third side. Now, these two sides might be congruent. These two sides might be congruent, but we don't know. They look like they are, but we don't know for sure. These two sides have to be congruent because they both use the same one. So that's what the reflexive property is telling you. If you're using the same side twice, it's going to be the same for both triangles or rectangles, whatever the shape is that you're using it in. So, like I said, look for a line segment that is going down the middle. You could use it here. You could use it here. You could use it here. This one it's got 1, 2, 3, 4 sides. 1, 2, 3, 4 sides in these two rectangles, right? This one right here, reflexive property. These others, who knows if they're the same or not? They don't look like they are. So we're going to use, I'll give you a couple of examples. Here's an example right here. So notice we have a rectangle. We have a diagonal going across from A to C, and this is the side that's being used in two different triangles. It's used in that triangle, triangle 1 and triangle 2. So we're going to start off by copying down our given. So if we just copy it down from the top with our statements, we're going to be using given as our reason. So everything has to be justified. So we're going to say BC congruent to AD. How do we know that? Well, we just copied it down. It was from the given. Okay. So the second one is angle BCA congruent to angle DAC. We just copied it down from the given, so that's also given. That's how we're going to justify it. Go ahead and mark it up here. So BC, that's from here to here. It starts at B, ends at C. That's this line segment. And AD goes from A to D. That's this line segment. So I'm going to make my congruence markings so that I can keep track of things. So this right here goes aside. Now BCA, we follow along. B to C to A. That's the angle symbol, so we know it's going to be an angle. BCA, so that's the angle we're tracing out. That's this angle. That one is going to be congruent to DAC. So we trace out DAC, and that's this angle. So we have an angle. So right now we have a side and an angle. We need three. We need side, angle, side, angle, side, angle. It would also work with angle, angle, side. So, but we don't have enough. So you look at what you have up here. Make sure you are on the lookout for anything like this. So hopefully this is something you notice before you even start the problem, that you're probably going to be able to use the reflexive property. So you know from the reflexive property that this side is used twice, and it's the same for both triangles. So we can mark it like this. We're using two tick marks, so we can tell it apart from this. So we're going to use our double markings. So now what we have is side, angle, side. Down here we don't have that third side, so we have to use AC. So from our picture now we should be able to see, okay, AC is the side we're using for this triangle. But isn't AC also the side we're using for this triangle? So we write AC congruent to AC. That's our third statement. Now, then the next question is, what do we put for the reason? If you look up here, we didn't just copy down AC. So your reasons are going to have either given if all you had to do was copy it down. If you had to figure it out somehow, something you know about the picture or you know a theorem or something like that, that's what you're going to tell how you figured it out. We figured this out because we know about the reflexive property, and that's going to be not definition. So it's the reflexive property of congruence. So just the reflexive property is good enough. And so those are the three things. Now you do have to be careful when you write this down. If you're going to keep track of this with SAS, don't use this order because sometimes this will be in the right order, sometimes it won't. You need to go back to the picture to double check and verify it. So we have a side, angle, side, SAS. So this won't always be in the right order for your triangle congruence terms. Now once you have that all figured out, everything written down here that you need, then you're done with this, and now it's time to go on to the proof statement. This is what you have to put down here. Now this one they're not telling you it's true at the beginning, so you can't just use given, but this is what you're going to write down. So triangle ABC congruent to triangle CDA, and our reason is going to be how we know that it's true, and that's what we figured out from here, side, angle, side. Like that.